Hello students, in this lecture again we are going to discuss few more basic points of thermodynamics. In the previous lecture you have seen the basic points of systems, surrounding and type of systems. Now let us talk about the another basic properties. Properties of system. So any system consists of two kinds of properties. First is the extensive property and second is the intensive property. Now what is the meaning of extensive property? Listen to me carefully, then write down those examples in it. So extensive properties, the name itself gives you an idea to what extent, to what amount. So basically those properties of system which depends upon the amount of substance, that is called as extensive property. So property of a system which depends upon amount of a substance, that is called as what? Extensive property, and which is independent of the amount, that is called as intensive property. For example, you take a beaker, add water into it. So if I talk about volume of water, so volume depends upon the amount of water added. If you add more water, the volume of water will increase. So that becomes the extensive property. But if I talk about density of water, so density of water at room temperature is 1 gram per ml. If you take 1 ml of water, if you take 100 ml of water, if you take 1000 ml of water, it will remain as what? 1 gram per ml. So density does not depend upon the amount and volume depend upon the amount. So volume becomes the extensive property and density becomes the intensive property of the system. Okay, I'll see more examples in it. So I'll write down more examples for extensive property and for intensive property and few more MCQ points in it. We'll discuss few more MCQ points in it. So the example of extensive properties are mass. Of course, mass depends upon the amount of substance. Volume depends upon the amount of substance. Work also depends upon the amount of effort taken, the amount of substance added to perform the work. Then you have heat. That also depends upon the amount of substance. The amount of heat which you obtain from a log of wood and 10 log of wood, that is different. So if you increase the amount of fuel, the amount of heat increases. Okay. Then number of moles depends upon the amount of substance. Then you have enthalpy. Enthalpy. So enthalpy denoted by capital H, which is the heat transfer at a constant pressure or total heat content of the system, also extensive property. We will see the difference between heat and enthalpy later. But you have seen this enthalpy in your 11th standard. So that is also an extensive property. Then you have a property of internal energy. If you remember from the first lecture that internal energy is denoted by U, capital U, and internal energy is basically sum of all different energies present in the system. Heat को हम लोग Q से represent करते हैं, small q से. ठीक है? Area, force, etc. All these are extensive property which depends upon the amount of substance. अच्छा एक चीज याद रखना, heat और enthalpy में क्या फर्क होता है? I'll tell you what. You need to remember this. What is the difference between heat and enthalpy? Heat is the basic flow of energy from a hot body to a cold body. Okay. And enthalpy is the flow of heat or the heat content of the system during a process at a constant pressure. For example, if I want to boil 1 ml of water, or if I want to boil 100 ml of water, the heat required will be different, but they will boil at a fixed temperature. That is 100 degrees Celsius. So at that time, at 100 degrees Celsius, and if the pressure is constant at that time, during the boiling of liquid, the pressure remains what? Constant. At that time, the heat content of the system will be called as enthalpy. and we actually calculate delta H. If you have remember from your 11th standard, enthalpy of ionization, then change in enthalpy of electron gain, then enthalpy of solution, hydration energy, all these things, the heat content of the system at a constant pressure, that is called as enthalpy, or flow of heat at a constant pressure, that is called as enthalpy. And normal heat क्या होता है? Normal heat ये होता है कि it is nothing but the flow of energy from a hot body to a cold body. बट एंथैल्पी क्या हो जाएगा? आपने हीट को रिस्ट्रिक्ट कर दिया कि एक प्रोसेस के अंदर जो हीट इन्वॉल्व हो रही है एट अ कांस्टेंट प्रेशर, दैट इज कॉल्ड एज एंथैल्पी ऑफ अ सिस्टम. फॉर एग्जांपल, आपके पास है enormous amount of heat, आपके पास बहुत सारा फ्यूल है, with that fuel you can produce lot of heat. But if you want to boil water, so a certain amount of water require a certain amount of heat at a constant pressure. So that flow of heat at a constant pressure becomes the enthalpy. Okay. For example, the enthalpy of vaporization of water. If I talk about vaporization of water converting from liquid state to the gaseous state, so at 100 degrees Celsius, the vaporization of water, that is the enthalpy of water, is around 40 kilojoules per mole. So suppose you have a heat of 1000 kilojoules per mole, so that will be your heat. But at that time, 1 mole of water require how much amount of heat change? That is a 40 kilojoules to convert into a vapor state. So that will be a fix. So basically, enthalpy is nothing but the flow of heat at a constant pressure, that is delta H. Okay, so ये मैंने हम लोग ने थोड़ा सा डिस्कशन देख लिया एंथैल्पी और हीट का. अच्छा, what is intensive property? Intensive property are those property which does not depend upon the amount. For example, मैंने आपको बताया density. For example, refractive index of glass prism जो आप लोगों ने निकाला था. In 10th standard, you have done this experiment where you calculate sin I by sin R. The refractive index will remain constant. It does not depend upon the amount of substance. Pressure is also an intensive property. Now, if I ask you pressure, तो आपके दिमाग में आएगा सर pressure तो extensive property होना चाहिए, because it depends upon the amount. जितना ज्यादा substance involved होगा उतना ज्यादा pressure exert कर सकते. For example, a car. एक कार को पुश करना है, so if 2 boys are pushing one car and 10 boys are pushing same car, so 10 boys will exert more pressure. मैंने yes, but pressure दो टाइप के होते हैं. एक होता है external pressure और एक होता है internal pressure. External pressure एक होता है internal pressure. Okay, and thermodynamics deals with the study of work, conversion of heat into the different forms of energy and matter into work. उसमें हम लोग बात करते हैं, तो work का होना बहुत जरूरी है. Work is the applied science. But question ये है कि work के लिए, to perform a work, to carry out a work, which pressure is important, internal or external? So you will think and you will give me an answer कि सर internal pressure होगा तो ज्यादा काम होगा. जैसे अगर मैं 2-3 लोग मिलके एक physical activity कर रहे, 2-3 people are involved in one physical activity as compared to single person, so they will exert more pressure, they will do more work. मैं yes, exactly. But I'm talking about the basic requirement of work. So let us try to understand what is the basic requirement of work, which pressure is more important. So there are two kinds of pressure, external pressure and internal pressure. For example, suppose we consider this a container enclosed with the airtight movable piston, और इसमें हम लोग ने गैस मॉलिक्यूल ऐड कर दिया, तो जो गैस मॉलिक्यूल्स वॉल पे कोलाइड करेंगे वो इंटरनल प्रेशर हो गया, और जो पिस्टन के थ्रू जो प्रेशर एक्सर्ट हो रहा है वो हो गया एक्सटर्नल प्रेशर ऑन द गैस, एंड दिस इज द इंटरनल प्रेशर एक्सर्टेड बाय गैस. सो एक्सटर्नल प्रेशर इज ऑन द गैस. मतलब अगर ये आपका सिस्टम है और ये सराउंडिंग है, तो सराउंडिंग का जो प्रेशर आ रहा है सिस्टम पे वो एक्सटर्नल प्रेशर हो गया, और अंदर जो प्रेशर है वो इंटरनल प्रेशर है. तो which pressure is more important? So basically, to do a work, the most important pressure is external pressure. For example, swimming is a kind of work. It's a kind of a physical activity. आप swimming के लिए जा रहे हो, आपको swimming बहुत अच्छी आती है, but problem is that कि there is no water in the swimming pool today. So what you will do? You cannot swim. Why? Because आपको swimming आती है, you have the internal pressure, you have the skills to swim, but there is no water to exert pressure on you. स्विमिंग करते वक्त क्या होता है, वाटर आप पे प्रेशर एक्सर्ट करता है और आप उसको ओवरकम करके आगे बढ़ जाते हो. सो इवन इफ यू हैव अ इंटरनल प्रेशर, external pressure is required to carry out work, क्योंकि work हमेशा एक्सटर्नल प्रेशर एक चैलेंज के थ्रू होता है. एक्सटर्नल प्रेशर को आप ओवरकम करोगे तो वर्क हो जाएगा. सेकेंड एग्जांपल, इफ आई गिव यू अ बॉल एंड आस्क यू टू थ्रो ऑन अ स्टंप, so first thing, you will look at the stump, you will aim it and you will throw it, and might be you hit the stump. So if you hit the stump, the work is done. So now if you say, okay sir, I have taken the ball, okay, I have aimed it, and now with my effort, with my force, I'm releasing it, so it went to the stump. Okay, okay, so work is done. Okay, so sir, I'm using the internal pressure. Okay, 1 minute. Can you do the same activity on space? It means what? Like, can you do the same activity on space where there is no air? When you're throwing the ball on earth, there will be an air opposing force, that will be opposing pressure. So you are overcoming the air, the direction of air, the opposing pressure. You are overcoming the opposing pressure, and then you are doing certain work. So the work is done only if there is opposing pressure. On space, there is no air. So when you release a ball, it will go in any direction, and work is force into displacement. Displacement is a vector quantity. If there is no direction to your force, work is not done. So even if you have an internal energy on space and you try to release the ball does not release in the proper direction because there is no air, there is no opposing force. So that is why we always consider external pressure to be very important to carry out work. And one more thing, the external pressure will always remain constant. For example, third example, if there is no exams, who will study? So if there is an exam, if there is a board exam, it will be common for everyone. The paper will be common for everyone, means the external pressure is common. Now it depends upon the internal pressure to overcome it. So external pressure is very important to carry out work, and external pressure will always remain constant. So if I apply a pressure on a gas, every molecule inside the container will experience same kind of pressure on it. That is why we say that pressure is an intensive property, and here we are much more precise towards the external pressure. Why? Because external pressure is responsible for carry out work. So work is always done against a constant external pressure. So that is why pressure is an intensive property. और याद रखना, हम लोग ज्यादा external pressure की बात कर रहे हैं जो हमेशा constant रहता है. It does not depend upon the amount. जैसा मैंने आपको example दिया कि बोर्ड एग्जाम का पेपर सबके लिए कॉमन होगा, तो external pressure will remain common. The internal pressure can change. So we are talking about external pressure as an intensive property. Secondly, the next one is the temperature. Now, temperature also comes in an intensive property. For example, if you want to boil 1 ml of water, at 1 ml of water, the boiling point is 100 degrees Celsius. If you want to boil 100 ml of water, the boiling point is 100 degrees Celsius. Matlab, the boiling point of water is remaining constant. If you take 1 ml of water, it will boil at 100 degree. 100 ml of water, it will boil at 100 degree. So the temperature is remaining constant for a process. But you know what? The heat does not remain constant. That is why I added heat into the extensive property. Reason क्या है? Because 1 ml को boil करने के लिए ज़्यादा heat लगेगा और 100 ml को boil करने के लिए कम heat. Sorry, 1 ml को boil करने के लिए you require less heat, and 100 ml को boil करने के लिए you require more heat. So heat will be different for 1 ml and 100 ml. But boiling point will remain what? Constant. Secondly, if you talk about the enthalpy, so that will be the heat content during the process. Okay. So now let us talk about few more points in it. So you understood why temperature, pressure, density, refractive index, or any other thing is which does not depend upon the amount is an intensive property. Or yaad rakhna, external pressure is very much important for carrying out work. अब आप बात कर लो viscosity की. Viscosity is the resistance to flow. So 1 ml honey और 100 ml honey का जो flow रहेगा वो same ही रहेगा, उसकी viscosity same ही रहेगी. So all these properties come under intensive properties. Now you have to make note of few points. The first most important point is that if you talk about density, so density is nothing but what? Mass upon volume. Mass is an extensive property, volume is also extensive property, but density is an intensive property. So remember, the ratio of two extensive properties is an intensive property. Remember this ratio. This is the ratio of two extensive property becomes what? Intensive property. Second point, whenever extensive property is quantified, it becomes intensive. It means what? It means what? If I say volume, तो आप बोलेंगे sir volume is a extensive property. But if I say volume per mole, 1 mole का volume कितना है, so it becomes intensive property because you are quantifying that value. One more example, for example, a class maximum 50 student can sit in a class, okay, maximum. So if I say number of students, so number of student can be any number, 1000, 10,000, 5, 10, 100, कितना भी हो सकता है number. But if I say number of student in my class, so you will say sir 50 because maximum 50 can sit. So number of student is extensive property. Okay. But if I say number of student per class, so it becomes an intensive property because आपने क्या किया, extensive property को quantify कर दिया, restrict कर दिया. जैसा postpaid होता है, calling के अंदर postpaid is extensive. कितना भी amount use करो, आपका bill आ जाएगा. It depends upon the amount. The billing depends upon the amount. But here, when you take a prepaid system, आप उसमें package लेते हो. So over there, the talk time, the usage of internet, depending upon the certain amount, उसके ऊपर आप नहीं जा सकते. मतलब आपने क्या कर दिया, value को quantify कर दिया. So when you quantify a particular extensive property, it becomes an intensive property. So prepaid is an intensive property and postpaid calling is an extensive property. Simple thing you need to understand. आप quantify कर रहे हो. Similarly, volume अगर मैंने बोल दिया extensive property, लेकिन अगर volume per glass बोल दिया तो एक ग्लास में समझो 100 ml आ सकता है. तो if I say volume per glass, so 100 ml, volume of 2 glasses, you will say 200 ml. So now what you have done, you have quantified a value. So volume can be any amount, but volume per mole becomes a fixed amount. So when you fix a particular extensive property, it becomes a intensive property. Okay, so this was all about extensive and intensive property, and I hope you understood why pressure temperature comes under intensive property and what is the difference between heat and enthalpy. याद रखना. अभी let's move on to the next basic part in this, that is called as let's talk about state variable. Now, what is the meaning of state variables? So state variables are those properties of a system which defines the state of a system. These are the properties, simple properties, which defines state of a system. जैसे फॉर एग्जाम्पल, अगर मुझे किसी पर्सन को डिफाइन करना है तो मैं उसकी हाइट कंसिडर करूंगा, कलर कंसिडर करूंगा, हेयर कंसिडर करूंगा, weight consider karunga, whether the guy is thin or is a fatty guy, is obese guy. So all these parameters are defining the height, the body, the mass, the face, the color, the hair. All these things defines a state of a person. Similarly, अगर किसी भी system का मुझे state define करना है, for example, आप ले लो gaseous system in a cylinder. गैस लिया है आपने सिलेंडर में, तो आप उसको कैसा डिफाइन करेंगे? तो आप मुझे बताओगे सर उसके अंदर नंबर ऑफ मोल्स ऑफ गैस कितनी है, उस गैस का वॉल्यूम कितना है, वो गैस का टेम्परेचर कितना है, वो गैस का प्रेशर कितना है, वो गैस की एंथैल्पी कितनी है, वो गैस की इंटरनल एनर्जी कितनी है, ठीक है, एंड वो गैस वर्क कितना कर सकता है, वो गैस में हीट कितना होगा, वो गैस की एंट्रोपी, इफ यू रिमेंबर एंट्रोपी स्टैंड्स फॉर द रैंडमनेस, दैट इज आल्सो एक्सटेंसिव प्रॉपर्टी है बिकॉज इट डिपेंड्स अपॉन अमाउंट. मैंने लिखा नहीं था बट याद रखना, एंट्रोपी व्हिच मेजर्ड द रैंडमनेस, आपको मैंने बताया था फर्स्ट लेक्चर में. सो एंट्रोपी हो गया, ऑल दीज थिंग्स व्हिच डिफाइंस द स्टेट ऑफ अ सिस्टम. एक सिस्टम का स्टेट डिफाइन कर सकते हैं, उसको हम स्टेट वेरिएबल बोलते हैं. And state variables can be of two type. Either it can be called as state function or path function. Now, what is state function? So state function are those variables which depends upon only on the initial and final state of a system. initial and final state of the system, they do not depend upon the path followed. For example, I give you two volume. Yeah, if I say I give you 200 ml of ammonia. If it decomposes completely, it will give you 1 mole of N2 and 3 moles of H2. If I suppose give you 200 ml of ammonia, suppose it decomposes completely, so it gives you 100 ml of nitrogen and 300 ml of hydrogen. So now initially the volume was 200 and the final volume, that is the volume of product, is what? 400. Okay. So if you see properly, the change in volume is of 200, 400 minus 200. So this is the initial volume of the gas and this is the gaseous reactant, this is the final volume. So here the volume do not depend upon the path followed. अब तुम अमोनिया को कैटलिस्ट डाल के ब्रेक करो, एक्सेस हीट डाल के ब्रेक करो, 1 घंटा लगा उस रिएक्शन के अंदर या 10 मिनट लग रहा है उस रिएक्शन में, मतलब पाथ के ऊपर वॉल्यूम डिपेंड नहीं कर रहा. तुमको मालूम है कि जब 200 ml अमोनिया ब्रेक होगा, so it will give you 400 ml of the reactant, whether it is prepared in a cylinder, in a metallic cylinder, आप उसके अंदर कर रहे हो reaction, you are adding catalyst, you are not adding catalyst, you are heating excess, you are not heating excess, मतलब you are taking different parameters to prepare, you are taking different conditions to prepare nitrogen gas and hydrogen gas. But if it decomposes completely, you will get 400 ml of the product. मतलब the volume do not depend upon the method or the path followed. It depends upon the initial state and the final state. So similarly, parameters like volume हो गया, temperature हो गया, number of moles हो गया, pressure हो गया, enthalpy हो गया, internal energy हो गया, एंट्रोपी हो गया, ये सब के सब स्टेट फंक्शन है. इट डिपेंड्स अपॉन ओनली ऑन द इनिशियल एंड फाइनल स्टेट ऑफ द सिस्टम. दे डू नॉट डिपेंड अपॉन द पाथ फॉलोड. अब फॉर एग्जांपल मैं अपने प्यून को बोल रहा हूँ कि प्लीज गेट मी 1 लीटर ऑफ डिस्टिल वाटर, 1 लीटर ऑफ वाटर, समझो बिस्लरी वाटर 1 लीटर का मंगाया मैंने. ओके, आई वाज आस्क्ड हिम टू बाय 1 लीटर बिस्लरी वाटर. सो हो सकता है कि दैट प्यून गोस टू अ नियर बाय शॉप एंड बाय इट, और हो सकता है दैट प्यून गोस टू फार अवे एंड बाय इट. So I am interested only in the volume, that is 1000 ml of water I need. Initially, I don't have any water. And after some time, I will get 1000 ml of water. So I am only interested in the initial and the final state, the amount. अब वो कहां से लेके आ रहा है, the path followed, I am not interested in this. कि वो कहीं नियर बाय शॉप से ला रहा है, it's going far away to bring that thing. So I'm not interested in the path followed. I am only interested in the initial and the final state. So all these are state functions because it depends upon the initial and final state of the system. But you know what? अगर प्यून बहुत नजदीक से मेरा काम कर लेगा, if it goes nearby shop and buy that, तो वो कम वर्क करेगा. If it does less work, less physical work, less heat will be released. क्योंकि जब वो physical work करेगा, if it start walking at a faster rate, it will lose out heat. When you work, when you do physical work, you burn out calories in that. So what is the meaning of burnout calories? You are losing energy. So if that person is losing energy and doing work, going nearby shop, that will be less as compared to the amount of work and the heat energy loss if he travels to a shop which is far away from my class. So very simple to understand कि अगर हम लोग बात कर रहे हैं वर्क की और हीट की, so work and heat, these two are those state variables which depend upon the path followed, do not depend upon the initial and final state. It depends upon the path followed. क्योंकि आपको मैं एक सिंपल एग्जांपल दिया कि मुझे वाटर अगर कोई नजदीक की शॉप से लाके देगा तो वो कम वर्क कर रहा है, तो लेस हीट इज रिलीज. अगर कोई दूर से जाके लेके आ रहा है तो वो ज्यादा वर्क कर रहा है, मोर हीट इज रिलीज. So at that time I can say that work and heat depends upon the path followed, does not depend upon the initial and final state. So path functions are work and heat, rest all are state functions. Okay guys, so I hope you have understood what is a path function and what is a state function. So state function are those which depends upon only on the initial and final state. Path function are those which depends upon the path followed. There is only two path functions, work and heat. याद रखने का. Okay. Now state function की एक property तो ये हो गई state function की कि these are those variables which depends upon only on the initial and final state of the system. Second property क्या है? If one of the value of in a particular system, listen to me carefully. In a particular system, if one of the value of state function is changed, the other values are automatically arranged. For example, suppose I've considered a gas enclosed into a container, जिसका प्रेशर हम लोग ने उस गैस का प्रेशर सपोज समझो ये गैस एनक्लोज है कंटेनर के अंदर. ओके, सपोज इस गैस का प्रेशर हम लोग ने चेंज करके पे 1 atm कर दिया. इनिशियली कुछ और था 2 atm, 1 atm कर दिया प्रेशर. सो प्रेशर इतना कर दिया हम लोगों ने, ठीक है. फिर इसका अगर हम लोग ने टेम्परेचर रख दिया 273.15 केल्विन, दैट इज 0 डिग्री सेल्सियस, और नंबर ऑफ गैस मैंने 1 मोल लिया है. सो अंडर दीज कंडीशन the volume occupied by the gas will be 22.4 liters, because this comes with the equation PV is equal to nRT. If you put the pressure as 1 atm, number of moles 1, R is 0.0821 liter atmosphere, the constant value of R, the temperature 273, so you get a value of 22.4. Now suppose you change the pressure to 2 atm, अगर आपने प्रेशर को डबल कर दिया, ठीक है ना. अगर प्रेशर को आप डबल कर रहे हो यहाँ पर, ठीक है, या प्रेशर को आपने सेम ही रखा, चलो सपोज प्रेशर आपने 1 atm ही रखा, समझो टेम्परेचर डबल कर दिया, 273 का डबल कर दिया हम लोगों ने. ओके, मतलब 0 डिग्री से 1 डिग्री पे लेके आ गए. सो व्हाट विल हैपन, the value will change and you will get a new value according to the change in temperature, you get a new value according to the change in pressure, or you get a new value, you can do change in moles. So you need to remember this, if one of the value of state function is changed, the other is automatically altered. Okay, ये याद रखना बहुत जरूरी है. So I'll clear this up. So this is all about state function and path function. And remember one more point, what is the meaning of thermodynamic equilibrium? ये सुन लो पहले, thermodynamic equilibrium क्या होता है. So thermodynamic equilibrium, basically it depends on 3 kinds of equilibrium: thermal equilibrium, chemical equilibrium, and mechanical equilibrium. Now what is the meaning of thermal equilibrium? If both system and surrounding maintains a constant temperature, or you can say if there is no exchange of heat, then it will be called as a thermal equilibrium. Okay, जब surrounding और system same temperature पे आ गए तो उसको हम लोग बोलते हैं thermal equilibrium. What is chemical equilibrium? If the chemical composition does not change within the time के साथ में chemical composition अगर कोई भी सिस्टम का चेंज नहीं हो रहा है तो उसको केमिकल इक्विलिब्रियम बोलेंगे. एंड मैकेनिकल इक्विलिब्रियम इज व्हेन द मूवमेंट ऑफ मैटर, इफ देयर इज नो मूवमेंट ऑफ मैटर इन द सिस्टम विद रिस्पेक्ट टू सराउंडिंग, मतलब सराउंडिंग से सिस्टम में या सिस्टम से सराउंडिंग में कोई मैटर आ जा नहीं रहा है, एक्सचेंज नहीं हो रहा है, तो उसको हम लोग बोलेंगे मैकेनिकल इक्विलिब्रियम. ओके गाइस, सो यू नीड टू रिमेंबर दिस के देयर आर 3 kinds of equilibrium: thermal equilibrium, mechanical equilibrium, and chemical equilibrium. All these 3 equilibriums are related to system and surrounding. If these equilibrium are being maintained in a particular system, the system is said to be under thermodynamic equilibrium. For example, a gas enclosed into a cylinder which is fixed with a weightless frictionless airtight movable piston. गैस उसमें आपने enclose कर दिया है, तो अब वो piston जब मूव ही नहीं कर रहा है, इसका मतलब क्या हो गया, एक्सटर्नल प्रेशर इज बैलेंस्ड बाय द इंटरनल प्रेशर. इसके लिए ना ऊपर जा रहा है पिस्टन ना नीचे आ रहा है, अंदर गैस है. द टेम्परेचर रिमेनिंग कांस्टेंट, अंदर का टेम्परेचर कांस्टेंट है, मतलब हीट एक्सचेंज नहीं हुआ है. अच्छा, कोई केमिकल रिएक्शंस आगे नहीं हो रहे हैं, मतलब जो रिएक्टेड प्रोडक्ट है अब वही है, कोई नया प्रोडक्ट नहीं बन रहा है या कोई नया रिएक्टेंट जनरेट नहीं कर रहे, आप ऐड नहीं कर रहे. सो केमिकल इक्विलिब्रियम भी है, थर्मल इक्विलिब्रियम भी है, और फिजिकल इक्विलिब्रियम मतलब मैकेनिकल इक्विलिब्रियम भी है, ना पिस्टन ऊपर जा रहा है ना नीचे आ रहा है. So at that time, that system is under thermodynamic equilibrium. But for example, you heat that system. So when you heat that system, the gas will gain some kinetic energy, start moving. It will hit the walls of piston. The piston will move upward and it will stop at the point. So जब वो piston move हो रहा था, जब at that time, when piston was moving, due to the collision of gaseous, highly kinetically energized gaseous molecule on the piston, when the piston was moving, at that time the equilibrium, thermodynamic equilibrium is disturbed. but after some time, the piston reaches to a particular point and it stops. So when it stops, at that time, again, a new equilibrium is set up in the system. So that is called as thermodynamic equilibrium, जहां पर thermal equilibrium, chemical equilibrium और mechanical equilibrium तीनों एक साथ exist करते हैं कि कोई नया चीज जनरेट नहीं हो रही है, इंटरनल एक्सटर्नल प्रेशर कांस्टेंट है, फ्लो ऑफ हीट नहीं हो रहा है सिस्टम सराउंडिंग से, तो दैट इज कॉल्ड एज thermodynamic equilibrium. Okay guys, so this was the another basic lecture with respect to thermodynamic equilibrium. Next lecture में we'll talk about heat, work and sign conventions of heat and work along with the internal energy. Till then, take care. Bye.